Okay, so hello everyone, let's get started. So first of all, welcome everyone to join our info session for this second RoCo challenge, which is going to happen during the IROS 2026. And we are very excited to have you all right here. And we are very excited to host this event and to see what embodied intelligence is going to happen. So before we get started into the details, let's hand it over to Professor Chang Liu and Professor Ziwei to give a brief introduction to this event.
Well, thanks, Rishan. And hello and welcome, everyone. Thank you for taking the time to join us for the second RoCo Assembly Challenge information session. I'm Chang Liu, an associate professor at CMU. And when we created this RoCo challenge, we started with a simple idea that our physical world is built from parts. And so that we believe the autonomous assembly is one of the ultimate benchmarks for the physical AI. And the goal here isn't just basic manipulation. We want to rigorously test a robot's physical intuition, long-term reasoning, and its ability to generalize to completely unseen structures. And of course, to achieve that vision, building a benchmark of this scale doesn't happen in vacuum. As you can see on this slide, this challenge is the result of an incredible global collaboration. And we have a dedicated team of researchers and engineers spanning from top institutes worldwide. This group has spent months collaborating across different time zones to bring the second iteration to life. And I want to sincerely thank all of them for their hard work. Yeah, and also this brings us to why we are so thrilled that you are all here. The goal of this competition is to push the system out of the lab and into the reality. By tackling the challenges we lay out this year, you're directly solving the bottlenecks that prevent robots from being genuinely useful in the real world. And we can't wait to see the innovation that you will bring to the table. With that, I would like to hand it over to Ziwei to introduce the collaborators.
Thanks, Chang Liu. So hello everyone. So I'm Ziwei Wang. I'm assistant professor at Nanyang Technological University. So yes, a huge thank you to each of you for signing up this event and joining us today for this second RoCo challenge at IROS 2026. So I want to express our deepest gratitude to our incredible partners and sponsors who have made this competition possible. So our partners include academia, world-renowned academia and research pioneers, including Carnegie Mellon University Robotics Institute, Nanyang Technological University, A-Star Singapore, UC Berkeley, Tsinghua University, and Central Lyon. And we also have incredible and visionary industry partners, including Dexmate, Sharpa, TARS, Eastward, and RoboForce. So their cutting-edge tools, resources, and shared commitment to this advanced robotic collaborative assembly are truly driving the future of industry automation. So please note that our ecosystem is still growing rapidly, and this sponsor list is still actively expanding. So with more partners join us in the next few weeks. Okay, so let's officially kick this off. So let me hand it over to Haichao and Rishan.
That's great. Thank you, professors. So let's get started to the details of the info session. So this is the outline for today's details of this competition. So we will first go over a little bit about the competition, so what it is and what we're gonna have for this competition. And then we're gonna dive into details of each track of this competition. And then we will go over to the conference logistics and some Q&A sessions for all of you. So what is RoCo Challenge? So RoCo Challenge stands for Robotic Collaborative Assembly Challenge. So This RoCo challenge focuses on evaluating robotic system across 4 core dimensions. So first is physics understanding. So we want the robots, they must possess a fundamental understanding of real-world physics, including like gravity, collisions, deformation or friction, and other physical interactions with the real world. And the second fundamental thing we want to evaluate is stack source manipulation. So the robot should be able to intentionally and effectively manipulate any objects they want. And the third thing we want to evaluate here is long horizon reasoning. So the robot should demonstrate awareness of its own capabilities and perform long horizon reasoning to execute very complex tasks in our physical world. And lastly, but last but not least, we also want to evaluate the generalizability. So the robot should be able to learn and adapt and generalize to unseen tasks, which demonstrate genuine intelligence rather than just memorizing the task. So to evaluate all these 4 abilities, we put them into the assembly task. We want to use assembly task to evaluate these 4 abilities. So the reason why I want to do that is we believe assembly is ubiquitous in everyday life, as most objects around us are composed of assembled components. So a robot capable of assembling and creating such structures not only demonstrates a high level of intelligence, but also requires it to be very useful and will be useful in our daily life. So that's why we put assembly as our main task in this challenge. So for this year, we extend the RoCo challenge into 2 tracks. So the first track is industrial board assembly. So the robot's going to perform some industrial level manipulation and assemble some industrial objects in this track. And the second track is called brick assembly. So we let the robots to use bricks to build assembly structures. And our goal for this competition is, there are 3 goals for this competition. So the first goal is that we want to use these 2 tracks to let the users develop cutting edge physical agents and to see how we can push the boundaries of physical AI. And the second goal is that we want to deploy and evaluate on real robots on these difficult tasks. And the third goal we want to achieve is that we want to bring the community together and build the connection between the researchers and get inspired from our colleagues. And for this year competition, we have put together a pretty amazing prize pool. So the total prize pool for now is going to be over $20,000 in cash prize. And we are very excited for all of you to compete into this prize pool. And during the on-site event, we're going to invite all on-site teams to the award ceremony and the networking event. And we want to provide this opportunity for all of the researchers to connect together and push the boundary of the physical AI. And we also want to thank our sponsors. So we're going to use the hardware from DexMate and Sharpa for the on-site challenge during the competition. And for this competition, we will have dedicated point of contact for each track, which is the industrial board assembly and brick assembly. So each POC is going to get in touch with all of the participating teams and support them to develop the solutions. And also all the teams will work with their POCs and organizing sponsors during the virtual preparation phase before the conference. So please feel free to communicate your questions with your POCs and direct your questions to our emails. So for this competition, our goal is to support teams to solve the challenge instead of really put the difficulty for the challenge. So in short, teams can use any approach to solve the task, and we will evaluate the solution based on 2 criteria. The first is the performance of the solution. So we want to see how capable the agents that the teams build, how many assemblies or how many tasks they can achieve. And the second criteria we are evaluating on is the speed of the solution. So basically, how long does the agent take to accomplish these tracks? And this is a brief schedule for the competition. So today it's May 21st. So we are hosting this info session. And after this info session, we're gonna let the participation teams to build their solutions until June 22nd, which is the deadline for teams to submit their virtual results. And after 1 week of the submission deadline, we're gonna announce the finalist teams, and then we're gonna prepare or support the finalist teams to develop their algorithms or develop their solutions. And during the IROS conference, we're gonna invite all the finalist teams to the on-site event, and then we're gonna compete on-site and deploy the algorithms to real robots. So that's the brief overview of the competition. Then we're gonna dive into the details of each track of these tasks. So the first is gonna be the industrial board assembly, and I'm gonna hand off to Haichao to introduce the task.
Okay, thank you, Ruixian, for the brief introduction of our goal of this challenge. And for the first task, we introduced the industrial board assembly. So next part, yes. So for the industrial board assembly, the first question is why we choose this track. We want to bridge the gap between precision engineering and physical AI, because now there are lots of working on pick and place and many household projects, but for the precision assembling of the industrial areas, it is not very fully researched. So the first reason is the high precision requirements of the sub-millimeter pegging hole accuracy and the complex contact physics of the real world. And the second one is the bimanual coordination. In this whole challenge, we choose two high-quality robots with 2 arms. So it requires seamless dual-arm collaboration to do the holding, manipulating, and reorientation, and also secure industrial parts. So it is very challenging for the bimanual manipulators to do the collaboration. So that's why we call this challenge RoCo. The last one is the sim-to-real benchmarking. So for this industrial board assembly and also for the Lego assembly parts, we have the simulation track and also the real-world track. So before the on-site challenge, we will announce the online challenge to do the assembly using exact sim. So the most challenging part for the sim to real is the domain gap. So how to solve this will be one key challenge and one key point to be the championship of this challenge. So I want all the participants to keep an eye on the simulation track and participate in the exact sim parts. And we have many collaborators working on the exact sim and also working on the simulation data. So how to do the sim to real, I think it will be very helpful to have a very good performance in the real world track. Okay, next. Yeah, here is the tasks on the standard task board for industrial tasks. Here we have this pad from the initial state. Next. Yes, and after the assembly of the robotic, we need to make all of the parts to be assembled on the task board. So the right-hand side image shows all of the results. As you can see, we have 4 kinds of tasks. The first one is scroll. As you can see in the left-hand side of this pad, we have different kinds of scrolls to be scrolled onto the small pad. And also we need to fasten multi-specification scrolls into the different thread holes to keep them will not be removed easily when we have external force. The second task is for connectors. It is also a very representative task in the industrial scenarios. We have many electrical interfaces such as RJ45, industrial pins, USB, including USB-A and USB-C, and also HDMI ports. So we need to pick them and then plug into the right ports. So it is also very challenging. We need to pick them and then we need to perceive the forces given to the robotic arm, and then we can judge whether the electrical interfaces are inserted to the right ports. The next one is for the cables. We need to insert the terminals in the right-hand side and route the flexible wires through our board constraints. And the goal is to ensure all of the cables are organized very well. And also, I think this cable task is inspired by TARS. They have just finished the Guinness record about this wire cable organization tasks for the robotic arms. The last one is for the batteries. As you can see in the left-hand side, we have 3 sides of batteries, from D cell, AA, and AAA to their correct compartments using the geometric cues. Okay, next. Okay, as you can see here, we have a very accurate meshing process of the 2 gears. So we not only need to insert the gears, we also need to mesh them. So it is also a very challenging part in the simulation and also in the real world. So you need to keep an eye on this very detailed physical interaction. Next. Yes, here is our first sub-track using the Dexmate Vega with a customized gripper. As I mentioned, we have 2 tracks in the industrial board assembly track. So in the left panel, in the left pad, we have all of the objects to be assembled in the right-hand side pad. So the robotic arm needs to pick all of the parts and then put them into the right ports. And in the first phase in the simulation track, with our collaboration with A-Star and the Dexmate and also the TARS customized gripper support, we have collected tons of simulation data for the collaborators, for the participants to train their own models. And we also encourage the participants to use some model-based and optimization-based, control-based methods to just use the foundation models to do this kind of very long horizon tasks. Okay, next. And for the next sub-track of industrial board assembly, we have invited Sharpa to provide many Sharpa wave hands and also their Sharpa North robotic embodiment to do the second sub-track of the same tasks to do the industrial board assembly. As you can see here, we have the very vivid video to make the robotic hands to grasp all of the parts, very small parts, and do the handover of the parts and before inserting them to the right pose. So after our first phase, we will also collect more than 200 samples of the long horizon tasks, and then we will provide a very mature model as our base model to train the very high def robotic embodiments via training and also for the module-based parts to the training of the module-based parts. And here we thank Sharpa to provide the hardware, software, and also the teleoperation solutions. Okay, next. Okay, for the score of the industrial board assembly, in the simulation track and also in the real world track, we have the preliminary, we have the primary metric as the total completion score. If the total completion score of several teams are seen, we will use the task completion time to be the secondary tiebreaker. Okay, for the final score, it is the mean of the normalized scores across, I mentioned, the 4 functional procedures. So each procedure contributes 25% of the total score, regardless of the number of components involved. So you need to make your own strategy to figure out which one is easy, which one is challenging, and you need to organize your own time on each task board area. And then I need to mention that we highly recommend to complete the simulation phase and submit your own simulation results to our committee to give a very fair performance evaluation. But we also accept proposals to provide the innovative solutions, and you can just finish and complete your proposals in the real world track in the IROS 2026. Okay, next. Okay, for the virtual phase, we will end this phase on 22 of June. As I mentioned, the simulation results are highly recommended. And if you have the simulation results, you also need to provide your solution report to give a brief introduction of your solution. If you don't have the simulation results, you need to give the proposal, a very detailed proposal of the real-world track in the IROS 2026 event. Okay, I think that's all about the first session. Ruixun? Yes, for the contact, I'm Haichao Liu, and we also have another colleague called Yuheng Zhou. You can contact us for the industry board assembly track for any technical and other kind of consults and questions. We will answer the questions in 2 days. And we also encourage you to join our Discord to have any discussions and communications with other participants. And also you can send emails to our official email, and we will also try to reply them as soon as possible. Okay, that's all of my parts, Ruixun.
Okay, thank you, Haichao. And next, I'm going to introduce the brick assembly task, which is going to be the second track in this RoCo challenge. So first of all, still the motivation why we want to do this brick assembly. Here are some listed like uniqueness of the brick assembly task. So first of all, it's a very standardized task. So as you can see from this picture, we're going to use just 7 different types of bricks. So the task itself is very standardized, and you can easily replicate at your own place. And second uniqueness of this task is that brick assembly requires like physically grounded intuition of the robots. So the robot needs to know to do what operation could assemble the object and what operation could actually break the object. And also the brick assembly requires very high precision. So when you want to assemble 2 bricks together, you need to align them very well in order to assemble them. And also brick assembly requires very long horizon reasoning. So in many structures, as you can see in this picture, it might include 1,000, 100 or 1,000 number of bricks. So even one single missed operation could like fail the whole task. So this very strong and long horizon dependency of the task make it very difficult. And also in many brick assembly tasks, it actually requires bimanual coordination. As you can see on this right picture, for some structures, you actually need 2 arms to coordinate together in order to like successfully assemble the bricks. And lastly, brick assembly is a very good platform to actually evaluate the generalizability of the agent. As you can see from this picture, even though we are only using 7 different components, the task is very vast, it's very large. So you actually have a theoretically infinite task space. So you can actually build anything you want. So the huge task space make it a very good platform to evaluate the generalizability of your robots. So based on these reasons, that's why we think brick assembly is a very good platform, and we include the brick assembly as a brand new track in this RoCo competition this year. So before we dive into the details of this task, I want to share, like, briefly talk about how we actually represent the brick assembly structures. So in our task, we're gonna represent a brick assembly using a JSON dictionary, and each node in the JSON dictionary is gonna represent a brick. So as you can see, a brick is represented in this form. So the brick ID here denotes the brick type. So it represents either it is a 1x2 brick, a 1x4 brick, or different dimension of the brick. And the XYZ represents the brick position in the structure. And the orientation represents the brick orientation in the structure. And we also have an additional color field to represent the color of this specific brick. So that's the brick assembly representation. And in this year, the brick assembly track is going to have two subtasks. So the first is called step assembly, and the second one is called sequence assembly. So for the first task, the step assembly, so this task actually tests the agent's ability to actually follow the command. So in this task, the agent only needs to perform a single step assembly. So for example, just place one brick at a desired location. So for example, so for this task, the input is going to include four different inputs. The first is going to be the initial assembly structure. So we're going to tell you what the initial structure looks like. And then we're also going to give you several like renderings of the initial structure. And we're also going to provide you the goal assembly structure. So this is actually the assembly structure you want to build. And we're also going to provide the renderings of this goal assembly structure. And how do we evaluate this performance of this step assembly task? So this is actually a binary metric. So either you succeed the task or you fail the task. So we're going to give 1 point for successfully achieving the goal structure from the starting structure. So here's an example of what the input of the this task looks like. So you're gonna get a initial assembly structure represented in the JSON file format, and you're also gonna get a bunch of renderings of how this initial assembly looks like. And you're also gonna get the goal assembly structure for the task, and you're also gonna have the a bunch of renderings of the goal assembly structure you want to achieve. So in this example task, you actually just want to place an additional blue brick onto the red brick. So it's a very simple task. And here's a example execution. So if you want to achieve, or if you want to get a score for this task, for this specific task, so you just need to grab the blue brick and place it onto the red brick. So that's the step assembly task. And the second task is called sequence assembly. So this type of task extends based on the first task. So it actually requires the robot to actually assemble a goal structure from scratch. So in this task, we're only gonna provide you the goal assembly structure, and we just assume there's nothing built before this. And we're also gonna provide the renderings of this goal assembly structure. And the evaluation metric is the score is calculated as the number of correctly assembled bricks. So after you assemble the structure, we're gonna count how many bricks you successfully assembled and use that as the score of this task. And here's another example. So for the goal structure, you're gonna get a JSON file which includes all the bricks in the structure. So in this case, we're gonna have 2 bricks, and we're gonna also provide a rendering of this structure from multiple views. And based on this input, this is another video showing an example execution. So for this example task, what you need to do is to use the red brick and use the blue brick to build the structure specified in the JSON file. So in this case, you just need to put the red brick onto the plate and then stack the blue brick onto the red brick to achieve the target assembly. So more details on the scoring metric. So for the type 1 task, the step assembly, So you're gonna get 1 point for completing one task. And for the type 2 task, the sequence assembly, we're gonna count the number of correctly assembled bricks for each task. So with like some number of type 1 tasks and some number of type 2 tasks, the total score is calculated as the sum of all the type 1 tasks you get, and also the square of all the type 2 tasks you get. So here's another example to give you a better understanding of how the score is going to calculate. So in this case, if we do this type 1 task as shown in this video and do the type 2 task as shown in this video, so these two videos shows two successful execution. So in this case, because you accomplished one type 1 task, and in this type 2 task, you accomplished two bricks. So in this case, you're going to get 1 plus 2 squared, which is going to get 5 points for these two executions. And here's another example of, for example, if you fail some steps of the task. So if you fail the type 1 task, so you're going to get 0 for this specific task. And for the type 2 task, if you successfully place the first brick, but you failed the second brick, then you're going to get 1 point for this task. And when you do the square and calculate the total final score, you're going to get 1 point for this whole execution. So that's basically the details of the brick assembly tasks. And during the offline preparation phase, we're gonna use also help the participation teams to develop their solutions in the simulation first. So in terms of the simulation, we're gonna use the BrickSim as our environment, and BrickSim is also built upon IsaacSim, so it actually inherits all the ecosystem of IsaacSim. And we're gonna release the link to the BrickSim after this info session. And for the on-site competition, when you deploy your algorithm to real robots, we're gonna use the Dexmate robot as shown in this picture. So the robot's gonna have two arms, so it's a bimanual robot with a head camera and also using two grippers. And for the virtual phase submission, so for this track, we actually require the participation team to submit their solution proposal. So in this proposal, you can talk as much detail as possible about how you want to solve this task. So for example, what approach you want to use and how you plan to do the sim to real transfer. And also you can talk about like brainstorm your unique ideas on how potentially you can achieve this task better than other teams. And because we're gonna release the BrickSim's environment, so you can also build your own solution in the BrickSim environment. So we actually, so this is not required. We are not requiring the simulation results, but we also highly recommend you to submit your preliminary results with your proposal. So this would highly increase the chance to be selected as finalist teams. So yeah, so if you have any questions, you can contact me or either Howei. So we are the main contact for the brick assembly track. And you can also join our Discord channel and also feel free to reach out using the email. Yeah, so that's basically the details of the tracks or the tasks we're gonna include in the RoCo challenge this year. And next, we're gonna briefly talk about some logistics about the conference. So the RoCo challenge this year is gonna happen during the IROS 2026, which is gonna happen in Pittsburgh, in United States. The event is gonna happen during the same time as the IROS conference, so it's gonna be on September 27th to October 1st. So if you want to participate for the offline ride to actually come to the event and come to the conference, so you need to register for the conference. And because we understand some teams might need visa to come to the Pittsburgh, to the United States, so we aim to release the finalist teams by the mid of June. So that will give enough time for people who need visa application, so they have enough time to apply for the visas. And here are some next steps the teams can do after this info session. So once you registered for the competition, before you actually do your work, please let us, please wait us to actually reach out to you, because we need to assign you and confirm you that you are assigned to the task track you want. And we will do our best to assign you to the task track based on your preference. And yeah, so after you register, we're gonna get in touch with you and confirm your registration and the assigned track. And after that, you can start develop your solution in the simulation environment. So for the industrial board assembly task, you can develop using the ASIC simulator. And for the brick assembly task, you can develop in the brick sim environment. And so if you made it to the final round, so then you just need to register for the conference and arrange your trip to our on-site competition. And even though if you didn't make to the final round, we still welcome all the participants to the on-site competition to witness the challenge. And we are very excited to see you all during the conference. And here are some questions we gathered from the registered teams. So I'm just gonna quickly go over them. Hopefully this answers some of your concerns or questions. So in terms of the methods, so what methods are allowed, or do we need to use data-driven or model-based hybrid methods? So the answer to this question is that we don't have any restrictions to the methods you use to develop your algorithms. So we welcome you to use any methods you see it suitable for this task. And are the teams allowed to use their own hardware? So also we don't have any restrictions on the hardware. So if you think you can bring your own hardwares, or you want to make some modifications to the hardwares we provide, you're welcome to do that. But the concern for that is that we're not going to support the additional hardware you use. So we're only going to support the hardware we provide. And the third question is, are human intervention allowed or teleoperation allowed? So we do not allow any human intervention or teleoperation once the robot starts doing the task. So during the deployment phase, we don't allow any human intervention unless you want to terminate the trial, so you can intervene it. And another question is that, do all team members need to register? So for this competition, when you register, we only require the team leader to register it. So all other team members, they do not need register for this competition. But if you are selected as a finalist and you want to come on site, then all the team members need to register for the conference. And when can we get access to the physical robot? So we're gonna have the robots be on site during the same time as the conference. So if you arrive on time for the conference, then you're gonna receive the robot and have access to them on the first day of IROS. And also another question is, will the assembly task be released before the competition? So we're actually gonna release some example tasks during the preparation. So during the offline or virtual development phase, we're gonna release some examples, which are gonna be very similar to the final task you use, but not exactly the same. So the last question is, will teams need to be in person? Yes, if you want to participate as the finalist and compete on site, then you need to be in person. Yeah, so that's basically everything we have for today's info session. And thank you again. And we really appreciate your time to join us. And we are very excited to see you during IROS and see you on site during the competition. And here are the QR codes for our website. And you can also scan this QR code on the right to register for your teams. Thank you.
Great, thank you, Ruixuan, and thank you all for participating in this info session. So looking forward to seeing your talented solutions and also your participation in IROS 2026. Let's push the boundaries of robotics and embody AI all together. So I think the live session, the info session is ended, right? Yeah, so thank you, and we will end this info session. And if you have any questions, please refer to our official website and also for the RoCo website and also for the contact email and also the Discords.